Armbian.
Hello everybody, I am NicoD. So I love ARM single board computers like this one, the NanoPi M4. And to run these ARM single board computers you of course need an operating system. So for that I use on most of my boards Armbian. Like here the Kadas Vim 3 is running Armbian Cinnamon. So Armbian has been created by Igor a lot of years ago and he is still maintaining it. So in this video Igor is going to show some of the gear that is used to maintain Armbian, also some of his test gear to test the images and his personal gear that he uses. So this is a video that I really wanted to see, so I hope you all will also enjoy it. I really did enjoy to watch it and to make it. So this is the start of a series of videos. We will see more of these videos. There are other parts of Armbian except the parts that Igor is doing, but that's for a later video. So now let's go watch what Igor has to say. So here we go!
Hi everyone, I will be presenting Armbian infrastructure, what is behind. So let's clear it first. Linux is not a distribution. Linux is a kernel and Armbian creates a part of it from ARM-based hardware. Let's look on what kind of tools we need to make it and to maintain it, what kind of infrastructure is behind, how things are managed. Main and most important infrastructure are people that cooperate with the goal to make those little devices alive. People that connect bits together into this whole big engine, a support cycle between machinery and our needs. Why do we do that? Needs to make useful project, needs to have fun, needs to learn. Core of our research and development is divided by chip vendors such as Allwinner, Rockchip, InLogic and others. Next is build engine development and its support, followed by desktop development, automatic testing, content delivery infrastructure, project management, legal and financial issues. We have some empty volunteering positions in case you want to do things in community behalf. What certain people do on the project will be presented in separate videos, so be not focusing on that. Today I will be present hardware part of the infrastructure, starting with the tools which we are using, followed by the tools I use. Most of the tools are a part of our personal possessions, but we are using them exclusively for things on Armbian. Okay, first we have more than 10 dedicated fast download mirrors around the globe so your download is very fast. Our redirector picks the closest mirror and serves to you automatically. We also have separate torrent network. It's also powered by around 10 dedicated servers, plus stuff which end users are serving on a random basis. Next, we have more than 10 powerful x86 build runners with 16 to 128 gigabytes of memory and between 16 and 128 CPU cores. We also have a few of ARM64 build hosts, and we have 2 automated test facilities with around 50 single board computers which are online most of the time. Most of this hardware is ours physically. All are running some form of Linux. Single board computers exclusively Armbian, while x86 devices are mainly powered by Ubuntu or Debian. Other used technologies worth mentioning, our source version control, we use GitHub for that. Also for CI we use GitHub actions which are triggering our build machines. Infrastructure performance is visualized with NetData and Grafana and modeled with Netbox. Website is WordPress based and forum is English community. Let's check my personal workspace where single board computer starts the journey. My desktop workstation is water-cooled Ryzen 3 950X with 80 gigabytes of memory. The need for so much memory is because it provides two GitHub runners with 32 gigabytes memory and 16 CPU cores each. Even both are running, I can normally use my workstation, and they don't get much work because there are 12 action runners. So workstation is hooked to 10 GB network, so both runners have fast access to NAS. Well, I have a GTX NVIDIA card hooked to one 4K and one 2K monitor. I do have a solid laboratory power supply, which is one of the most important tools, so I'm always sure that the powering is okay. Soldering station from ERSA I use from time to time. There's a lot of small electronics components, SD cards, eMMC modules, N2 drives, oscilloscope to check signals and protocols, smart network switch is below in the desk, as well as HDMI switch and DIN rail console. HDMI switch is used for development, or it is used as my second monitor when I don't have any single board computers hooked there. I can hook up to 7 SBCs at once, and I can switch them with a keyboard. They share a mouse, an additional USB hub with a bunch of wireless dongles and other devices that are tested on the way. I have two powerful NAS servers in the rack. Primary is using Supermicro X11 with dual 10 GB network card. It has 128 gigabytes of memory, error correction memory. It provides network shares to build runners, my workstation, and other devices on the network. It also provides main AirSync service for other mirrors. It provides APT cache and it also runs a few of KVM virtual machines. NAS has two Z-RAID Type 1 arrays. It has 16 terabytes of mechanical and 4 terabytes of solid state array. Both arrays have speed and security gained for cost of one additional drive. Around 100 gigabytes of memory is used for write caching of both arrays, while mechanical arrays has additional 500 gigabytes of NVMe SSD read cache. NAS reliability is extremely important, so I have a hot swap backup NAS. It also has a dual 10 GB, but it's much less performant. CPU is lighter, it has only 32 gigabytes of memory, and it only has 20 terabytes of mechanical drive, all in Z-RAID 1 mode. It switches one per day, sync, primary NAS, and switches off. So it's basically just there, waiting for troubles. Most powerful machine is in the rack is water-cooled Threadripper 399X with extreme overclocking capabilities. It's equipped with 265 gigabytes of error correction memory and PCIe 4 SSD in write 0 mode. So it's really fast. It hosts 4 runners with 80 gigabytes of dedicated memory and 64 cores each. All are feeding data to the NAS, which due to its luxury of resources have no troubles to read packages and write artifacts with several gigabits at once while serving web torrents and sync data to other servers. When making a release, this is very important feature since we need to produce around 600 images. Main build script cuts this huge job down into 40 chunks, and on these 40 chunks, those 40 chunks are fed to 12 to 14 build runners in our network. 4 are those running on this Threadripper, and 2 are running on my desktop. The rest are elsewhere. This Threadripper is more than twice as fast as second best runner, and all together, all those runners need around between 4 and 5 hours to produce 600 images to deploy them to the NAS. Other important part of the infrastructure is automated testing of software support reliability. So to secure that upgrades are not broken, that you are satisfied, basically. We have several scripts which can power the devices on and off, launch upgrades, switch kernels, reboots machines, measure network utilization, measures wireless network utilization, collect performance analysis from SBC bench, measure memory performance, storage speed, temperature, and so on and so on. So we know very well what is wrong with the hardware, but we don't have option to fix bugs because we simply don't have resources. It's very expensive to fix bugs, and we have almost no income, and we have no full-time personnel. Even writing those bugs down is overwhelming. Currently, we run those tests on hardware prior to major releases so that we have some picture of what works, what not, or to have some overall stability over the build, over the whole build. We are working on to merge our labs into one whole, so those testing and monitoring resources can be common, not just mine, and so that my lab is shared with other developers. They can check check and log into devices which are in my lab, check their serial console, check their video output, which can all be done remotely. This part is not completely finished yet because HDMI switch is currently connected just to the monitor and it's not yet streaming the data. I hope you have enjoyed this small presentation. There is a lot more, but the time is limited for this presentation as well. So I hope you might also join us so we can move things together. Together we can make a lot more. Thank you, NicoD, for motivating me for doing this. Otherwise, I wouldn't do this video on my own. Thank you.